Welcome to Khizar School of Advanced Chemistry. Enthalpy cycle. To check the solubility of an ionic compound in aqueous medium, a cycle is drawn that is known as enthalpy cycle. Basically, enthalpy of solution is calculated with the help of this cycle. To calculate the enthalpy of solution, we need enthalpy of lattice energy plus enthalpy of hydration energy of the gaseous ions. Or we can also calculate the enthalpy of solution with the help of enthalpy of formation data. For example, when calcium sulfate is dissolved in aqueous medium, then we can write the equation like that. There is a formation of calcium 2 positive aqueous ion and SO4 2 negative aqueous ion. This expression can also be written as, instead of these individual calcium and sulfate ions, we can write as calcium sulfate aqueous. This is one and the same thing. You can also use this format as well. To complete the solubility or enthalpy cycle, we need two similar gaseous ions. Now, one should be calcium gaseous ion and other should be the sulfate gaseous ion. These two gaseous ions can combine together to make a solid lattice of calcium sulfate, and the enthalpy change in this case is known as lattice enthalpy or lattice energy. This arrow is showing the enthalpy of solution, the first one. When gaseous ions are dissolved in water to make infinite dilute solution, this enthalpy of reaction is known as enthalpy of hydration. As in case of calcium gaseous ion, same is the case with the sulfate ion. When sulfate ion is dissolved in water, its enthalpy is known as enthalpy of hydration of sulfate ion. Now I have completed our cycle. Just have a look. This cycle contains three main routes or three main arrows. One for the enthalpy of hydration energy, second for the enthalpy of lattice energy, and the last one is showing the enthalpy of solution. To find the answer of enthalpy of solution, I am applying my own rule or technique, you can say Khizar rule. According to this rule, treat these three arrows like vectors. And then I am going to find the answer of the vector of enthalpy of solution by making it a resultant vector. This Khizar rule can also be applied for all type of energy cycles. Resultant vector is basically made by the addition of other vectors. What is the resultant vector? A vector that heads meet with the head of other vector and its tail meet with the tail of other vectors. To make this arrangement, I have to flip or reverse the vector of lattice energy so as to meet tail to the tail of the resultant vector. When we reverse the direction of any vector, its magnitude also becomes reverse. The vector of enthalpy of solution has become a resultant vector. Its value can be calculated by the sum of other vectors. So, the expression of the enthalpy of the solution is equal to minus small bracket lattice energy plus again small brackets and hydration energy of the calcium ion and sulfate ion both, or We can also write this expression in a simple way. Enthalpy of solution is equal to sum of all type of hydration energies minus enthalpy of the lattice energy. If the answer of the enthalpy of solution is a positive integer or positive value, then the compound or the salt will be insoluble at room temperature or less soluble in water at room temperature. If the answer of this enthalpy of solution is negative, then this compound will be soluble or more soluble at room temperature. So, the nature of the solubility of any compound, of any ionic compound, can be predicted just by drawing this cycle, this enthalpy cycle or solubility cycle, without performing any experiment. Remember, the values of the enthalpy of the hydration and enthalpy of the lattice energies are always negative. When we put these values to find the answer of enthalpy of solution, the values, the integer of these enthalpy of hydration and enthalpy of energy must be in negative form.